Hello, and welcome to the VMware NSX Security module. This module includes 3 lessons. Lesson 1, VMware NSX Security Overview. Lesson 2, Logical Firewalls. Lesson 3, Service Composer. At the end of this module, you should be able to describe the main challenges of the traditional security model, explain how the VMware NSX Next Generation security model overcomes these challenges, describe the main differences between NSX Distributed Firewall and other alternatives, articulate the VMware NSX Security Foundation and benefits, describe the functions of VMware NSX Logical Firewalls, VMware NSX Edge Firewall, and Distributed Firewall. Explain how Service Composer works to secure the data center. Lesson 1 provides an overview of security in the data center today. This lesson covers the following topics: evolution of firewall placement, security challenges in the data center today, how the VMware NSX security model overcomes these challenges, VMware NSX embedded security functions in the hypervisor, how VMware NSX differs from traditional physical and virtual firewalls. Data center routing has evolved from standalone physical firewalls to software firewalls installed in virtual machines, to today's most sophisticated firewall built directly into a host hypervisor kernel. Traditional security solutions are not optimized for software-defined data center or SDDC, resulting in negative impact to agility and cost. For example, traditional perimeter-centric firewall and intrusion detection and prevention systems cannot sufficiently protect the inside of a data center. There is lack of isolation. Security controls within the guest are prone to attacks. Due to lack of application context, there is no visibility into application, process, file, user, or overall security posture. There are performance impacts also. The requirement of in-guest agents are resource-intensive. Some organizations choose to use so-called best-of-breed security products. That approach adds deployment and troubleshooting complexity. Lack of interoperability and automation create manual, error-prone workflows. There is also very limited visibility into workload security posture and policies. Let's take a closer look at some of these challenges. Businesses today are routinely faced with the need to adapt to a changing landscape and keep pace with business and security requirements. Each of these changes requires IT and security organizations to support them. Despite the substantial investments in protecting data centers, businesses are still experiencing network and data breaches. A lot of customers have come to realize that the networking industry has been approaching security with an outdated foundational model. The legacy approach believes that as long as you thoroughly secure the perimeter through devices such as NSX Edge firewalls or intrusion prevention systems, you would be able to keep threats on the outside and guard against threats, while the inside of the data center remains trusted. However, we continue to see that threats are still able to make it into the data center, whether through the data center perimeter firewall or other means. Till today, the most prevalent approach to data center security has been a perimeter-centric model. This approach does not provide protection from threats that can enter the data center via legitimate users, often targeting internal devices. Once those threats are inside the data center, they can move easily within the data center. For example, malware targets low-priority systems with lower protection and then moves laterally among servers through the data center network. However, with traditional security mechanisms, traffic between servers is nearly impossible to secure. Eventually, malware will move to a target system where it can collect information and begin exfiltration. Perimeter defense architectures only leverage north-south control points at the perimeter, but provide little or no lateral control inside the perimeter, making it insufficient for addressing the explosion of east-west traffic. Because the traditional focus has so disproportionately been placed on securing the data center perimeter, the inside of the data center has been left relatively unguarded. What becomes obvious when we take a step back is that we need a lot more security inside the data center. Ideally, many businesses would like to adopt some version of the zero trust model, which assumes that threats can be anywhere, including inside the data center, and asserts that all network traffic should be considered untrusted. Ideally, businesses would like to provide security between every virtual machine inside the data center to ensure security is applied everywhere. As a result, they would deploy firewalls within the data center to protect critical systems. However, this has proven to be very difficult to accomplish with an underlying problem foundation. The first approach is to apply physical firewalls inside the data center, much like what is done at the perimeter. The second approach is to apply virtual firewalls. Click each approach to learn more. A high security context provides deeper level knowledge of the traffic types and patterns. High isolation means that management is isolated, centralized, and therefore easier to manage. Traditional data center products have an inverse relationship between context and isolation. Until now, data center security administrators have been forced to choose between security products that offer high context with low isolation, or low context with high isolation. There is a classic debate on host-based versus network-based security. Host-based proponents argue that integration into the operating system and application enables a higher degree of context, which is true. It also puts security controls directly into the attack zone. What is the first thing malware does when it lands? It disables antivirus. Network-based controls avoid this problem by being outside the attack zone. But for the most part, they have no idea what is happening with the application, process, file, or user. So you have to make a choice. Do you want meaningful controls, context, or do you want effective controls, isolation? Clearly, you need both, and the virtualization layer, that is the hypervisor, is in a unique position to provide visibility into the guest from a trusted position isolated from the guest's domain. In other words, it provides both context and isolation. We will talk about hypervisor-based security in just a moment. In-guest agents can become resource-intensive and difficult to manage. Traditional security products require these agents as a means of inspecting files and traffic to find rogue activities. As workloads become increasingly mobile, it can be difficult to maintain security posture using existing security tools. For example, VMware vSphere Distributed Resource Scheduler can automate the migration of workloads within a cluster to achieve better distribution of CPU and memory utilization. But it does not enforce a security posture on the workload. You can migrate workloads to a new cluster with new storage, or perform cross-vCenter migration that allows the workload to consume new compute, new storage, and new networking resources. However, there is no security enforcement for the workload during or after the migration. Traditional data center security products do not share state information with one another. This makes the automation and orchestration of security policies very difficult. Manual workflows are often required due to lack of interoperability and automation across best-of-breed security products. Endpoint control events do not trigger network controls. An alert in one tool is not seen or acknowledged by another. Adding more security products often means adding more administration work. The inability to share state information among traditional data center security products impacts a person's ability to deploy new applications and services into the network. VMware NSX is the next generation security model that helps you overcome all these challenges. As you can see, security services, along with other networking functions, are embedded in the hypervisor layer. VMware NSX provides a hypervisor-based in-kernel distributed firewall service to the entire data center. By embedding security functions into the hypervisor, we can take advantage of some significant benefits. With this approach, we are enabled to realize very high throughput rates and secure east-west traffic between every single virtual machine. This is done natively to the platform by embedding these functions in every hypervisor in the data center. VMware NSX provides built-in services to manage the security posture of workloads at scale, including guest introspection and network introspection. VMware NSX also enables the use of third-party security services. This network hypervisor is an abstraction layer that sits between the underlying physical infrastructure and virtual networks above. Each of these virtualized networks are able to act in complete isolation from one another, each with their own virtualized compute and virtualized storage. Because each of these networks is isolated by default, there is no way for them to communicate with one another unless they are explicitly permitted to do so. VMware NSX inherently has a more secure foundation. This ability to create entire networks fully in software brings with it some new implications on how security can be applied. First, as mentioned before, the virtual networks are isolated from one another by default. This means that there is no risk of unrelated streams of data communicating with each other. Secondly, by embedding security functions into the hypervisor, we are effectively able to provide firewall capability at every virtual machine all the way down to the individual virtual network interface, a level of fine-grained security that has previously been unreachable and is not possible through legacy physical appliances. This enables us to limit the spread of threats inside the data center in a way that is not otherwise possible. The term microsegmentation refers to the use of fine-grained policies and network controls to enable security inside the data center, preventing the lateral spread of threats once they have overcome perimeter defenses. It is important to understand that we are not talking about replacing the north-south firewall. In fact, you will likely leverage hardware-based performance and throughput capacity for a very long time at the perimeter of the data center. However, it is important to understand that there is a huge difference between physical or virtual firewall and distributed firewall. Hardware-based firewalls are designed to deliver high performance, high-capacity throughput, typically ranging from 2 to 30 gigabytes per second, with some of the most powerful chassis-based solutions exceeding 100 gigabytes per second. Virtual firewalls are effectively the same from an operational standpoint, but often reduce feature sets and deliver far less throughput capacity, in the range of 1 to 3 gigabytes per second. The big difference with a distributed firewall solution is the combination of an automated operational model and scale-out throughput performance. Using an SDDC approach, firewall policies are provisioned with and enforced at each virtual machine's virtual interface. The distributed firewall function is done in the hypervisor kernel and delivers 30 gigabytes per hypervisor. So, The more hypervisor hosts you have, the more east-west firewall capacity you have. VMware NSX is also designed to see everything. It can examine a virtual machine's workload in a way that was previously unattainable. This level of visibility enables you to make much more intelligent decisions about your network and security policy.